Hello my dear student, welcome to EPG Pathshala. I am Anchal Srivastava from Department of Physics, Institute of Science, Banaras Hindu University. Today we are going to discuss about the module named Magnetic Data Storage under the paper Nanoscience and Technology 2. After completing this module, the student will be able to learn a few basic processes which shows how the memory storage, accessing and magnetic data storage. Also learn about the various type of secondary storage devices with our Winchester disk, magnetic drum, magnetic tapes, optical disc, magnetic disc, etc. Also learn about important parameters for data storage are addresses, seek time, latency time, data transfer time, etc. We will also learn about the magnetic nanostructure can be divided into different groups based on their properties and morphologies. Magnetic materials are used in various day-to-day applications such as in motors, generators, electromagnets, low and high frequency transformers, magnetic field screening, permanent magnets, loudspeakers, analog and digital data storage, telecommunication, etc. Some of the widely used permanent magnetic materials are magnetite, magnetic carbon steel, alnico magnet, alloys based on aluminum, cobalt and nickel, cobalt platinum magnet, hard ferrite magnets, samarium cobalt, neodymium iron boron magnets, and samarium iron nitride. The oxide ferrimagnetic material, ferrites and garnets, etc. Let us discuss the storage devices. Data storage is the recording or storing of information or data in a storage medium. Recording is accomplished by virtually any form of energy. DNA and RNA, handwriting, phonographic recording, magnetic tape, and optical disc are all examples of storage media. Electronic data storage requires electrical power to store and retrieve data. Data storage in a digital machine readable medium is sometimes called digital data. Computer data storage is one of the core functions of general purpose computer. Here, whatever the module you are seeing, this is also stored through a digital data system. Electronic documents can be stored in a much less space than paper documents. Barcodes and magnetic ink character recognition, known as MICR, are two ways of recording machine readable data on paper. Some of the photographs has been shown in the figure of storage devices. The most common form of permanent data storage used in modem computer, hard disk and archival tapes represents data in magnetized bar on the surface of a thin medium, where writing and reading of the data requires mechanical movement of the medium. This type of data storage was used in the very first computers at the end of 1940s. In the succeeding 55 years, the technology has been improved to an extent that it's just and remarkable an improvement to computer electronic circuitry over the same period. Magnetic storage in the form of wire recording, audio recording on a wire, are publicized by Overling Smith in the September 8, 1888 issue of Electrical World. Early magnetic storage devices were designed to record analog audio signals. Computers and now most audio and video magnetic storage devices record digital data. In the late 1940, when the designers of the first computer needed to provide fast storage retrieval of digital data, they could draw on the technology for recording analog audio information using magnetism that has been developed over the preceding 50 years. The earliest digital magnetic stores used induction to read the information stored. The medium is moved past a read head, which is electromagnet, used in reverse. Sometimes the same is at right head. The change in magnetization direction induces a current in the electromagnet wires. In modern devices, the magnetization is sensed by other means, but the tradition is maintained that the two states of raw bits are represented by a transition or no transition in the direction of magnetization. Several magnetic data storage devices has been shown in figure. The history of magnetic disk storage for digital data has a precise beginning. The first such storage was the result of an undertaking by IBM from their new 1952 San Jose, California laboratories to develop both a disk store, the IBM 350, and the computer system that was based around the use of online storage. The RAMAC, Random Access Method for Accounting and Control, which is known as RAMAC, in 1956. For the first 20 years, the development of disk, they were very much at IBM story. Nowadays, there are other pushing technology, although IBM remains an important player. The final IBM 350 disk storage has 50 24-inch diameter double-side disk platters on a spindle rotating at 1200 rpm. There was one dual head mechanism that was inserted between disk to read the disk above or that below. The head had to be retracted and moved vertically to the appropriate gap when there was a change in the surface being read. One problem with large rotating disks is that they wobble, called runout. To get the head consistently near enough to the surface, it was necessary to force it close using air under pressure pumped to the head. The head was stopped for contracting the disk surface by a jet of air from the head forming an air bearing that causes the head to float like a hydrocraft at 800 micro inches to 20 micrometer. This allowed the IBM 350 to store 100 bit per inch with track speed at 20 per inch. Magnetic materials are used in various day-to-day applications such as in motors, generators, electromagnets, low and high frequency transformers, magnetic field screening, permanent magnets, loudspeakers, analog and digital data storage, telecommunication, etc. Some of the widely used permanent magnetic materials are magnetite, magnetic carbon steel, alnico magnet, which is alloys based on aluminum, cobalt and nickel, cobalt platinum magnet, hard ferrite magnets, samarium cobalt, neodymium iron boron magnets, and samarium iron nitride. The oxide ferrimagnetic materials, which is ferrite or garnets, etc., are discovered in the early 1940s, and they are still occupy a key position among the technologically important magnetic material. In simple words, without magnetic material, we cannot think about modern technological revolutions. The present trend in the magnetic material research is on nanometer size material. The main emphasis at present are on synthesis, characterization, studies on differences in properties with respect to the corresponding bulk counterpart, and on the application of magnetic nanomaterials for the benefit of mankind. Magnetic nanoparticles have been the subject of much research interest even before 1950s. Because of the surge in the field of nanoscience and nanotechnology, studies on nanomagnetism emerged as a major area of research due to the potential application of the nano-sized magnetic materials. Thus, investigation of magnetic nanoparticle is a subject of intensive research from the viewpoint of probing their magnetic behavior, size and surface effect, and their applications. Modern scientific research Modern scientific research is aiming at improving and enhancing capabilities of device based on spintronics, spin plus electronics. This is towards the development of a smallest and cheapest microchip for use in computers, cell phones, and other electronic components for military application. Some of the major applications of magnetic nanoparticles are in information storage, where single nanoparticle can act as an individual bit of information, providing high density data storage. In magneto-optical switches, sensor based on giant magnetoresistance (GMR), magnetically controllable single electron transistor device. In magnetic resonance imaging (MRI), targeted drug delivery, detection of biomolecular interactions, detection of DNA hybridization, diluted magnetic semiconductor, etc. Let us discuss the various type of secondary storage devices. Secondary storage devices are essential as the size of primary storage or main memory in every computer is limited. With this, the computer can only accommodate a limited size program and data. To carry out big jobs like commercial data processing, it becomes essential that data be held in some expensive form of storage. This is achieved through a secondary storage devices. It is also called as external storage and can hold data either sequentially or at random. You should always keep in mind that the data in secondary storage devices is not directly accessible and has to be routed through the main storage for processing. Type of secondary storage devices in computers are magnetic tape, magnetic disk, magnetic drum. So let us discuss the magnetic tape. So magnetic tapes are used for recording and storing data for computer processing. It is a plastic reel similar to the long length of movie film. A tape is usually half-inch wide and 240 feet in length, and it coated with particle of ferric oxide on which data can be recorded magnetically. The process of reading and writing of data is carried out on a device called tape drive, and the record on magnetic tape are stored in sequential order. Let us talk about magnetic disk. Magnetic disk is another type of secondary storage device known as random direct access, as it permits direct accessing of data. An individual disk is a circular metal plate coated on both sides by ferrous oxide material. Data is recorded in the form of magnetized spots on the track of the disk. A spot representing the presence of 1 and its absence by 0, enabling representing of data in binary form. The surface of magnetic disk is divided into number of invisible concentric circular called track, and these tracks are further subdivided into sectors or blocks, each its own unique addresses to facilitate the location of data, and the disk move on vertical rotating spindle. Reading writing on the disk is comprised by means of series of read write head which are placed close to the surface of the disk. It is good to know that data on the magnetic disk can be accessed again and again. It can also recorded erasing older information. Let us discuss about magnetic drum. It is a metallic cylindrical coated with spherical magnetic alloy. Data is stored in this surface at minute magnetized spoke arranged in binary form in series of parallel circular track. The drum rotates at the constant speed and data is recorded, retrieved by the read-write head, one for each track. The magnetic drum provides random access storage. Now let us discuss reading and writing in secondary storage devices. In order to store all the information permanently, the computer secondary memory devices are used. These secondary storage devices are used to store large files and data and then can be reloaded into the main memory. For processing, when the file are saved into the computer, you can retrieve it as and when required by the user. The secondary storage device has a large storage capacity and is cheaper than primary storage. The magnetic memories are used for secondary storage and thus they are semiconducting devices. The magnetic memories are divided into two categories: carryable memories, for example floppy disk, compact disk or magnetic disk, and non-carryable memories, for example hard disk. The purpose secondary storage devices are magnetic disk, magnetic tape and CD-ROM. Let us discuss the magnetic disk. The magnetic disks are made up of synthetic plastic material. The disk plotter is coated with both sides and the surface is stored. Similarly, the magnetic disks are divided into two types, floppy disk and hard disk. Now, come to addresses, seek time, latency time, and data transfer time has been discussed. Let us discuss the address. Address means the number of cylinder, number of tracks, and number of sectors from which user want to read the data. With the help of these read and write head, we can also read the data from the disk, and we can also store some data onto the disk. With rotating drive, the seek time measures the time it takes the head assembly on the actuator arm to travel to the track of the disk where the data will be read or written. The data on the media is stored in sectors which are arranged in parallel circle track, concentric or spiral depending upon the device type. And there is an actuator with an arm that suspends a head that can transfer data with the medium. When the drive needs to read or write a certain sector, it determines in which track the sector is located. It then uses the actuator to move the head to that particular track. If the initial location of the head was desired track, then the seek time would be 0. If the initial track was the outmost edge of the medium and the desired track was at innermost edge, then the seek time would be maximum for that drive. Seek times are not linear compared with the seek distance traveled because of the factor of acceleration and deceleration of the actuator arm. Let us discuss the latency time. The time required to bring the particular track to the desired location means the total time to bring the correct the sector for reading or for the read and write head. This is also called a average time. Data transfer time. The total time which is required for reading and writing the data to the disk is known as data transfer time. Let us discuss the data recording and magnetic domains. Separate sides of magnetic disk can be magnetized in one of the two possible ways, which represent 0 or 1. For example, 1 bit. Such magnetized area is called a magnetic domain. It is a micro-size magnet on the surface of the hard disk which has certain orientation of southern or northern magnetic pole. To record 1 bit of data, a magnetic head created a specifically desired magnetic field, directed magnetic field. A magnetization vector of the domain remains unchanged for a long time after the magnetic head stops affecting the magnetic surface. Storage density, which is amount of information which can be stored in 1 unit of the plate surface, depends on the size of domains. Commonly used values of storage densities are BSP, byte per square inch, a real density, amount of information which can be stored in 1 square inch of magnetic disk. TPI, the tracks per inch value. This is defined as the value which shows the density of tracks stored in a magnetic plate. It is measured in tracks per inch. Bits per inch, BPI. It is the linear or recording density value which shows the density of data stored in a track. it is measured in bit per inch of a track. Impossibility of infinite decrease of domain size is stipulated by following factors. The size of the magnetic head. Nowadays, it determines the size of magnetized area, the domains, the decrease of readout signal level and the increase of noise level in it. Also, spontaneous self-demagnetization of the domain caused by thermal effect. Now discuss assessing data. Data access typically refers to software and activities related to storing, retrieving, or acting on data housed in the database or other repository. Two fundamental types of data access exist. The first one is sequential access, and the second one is the random access. Sequential access means as in magnetic tape, for example, and in random access as in indexed media. Data access crucially involves authorization to access different data repositories. Data access can help distinguish the abilities of the administrator and user. For example, the administrator may have the ability to remove, edit, and add data, while general users may not even have read-write if they lack access to the particular information. Historically, each repository, including each different database, file system, etc., might require the use of different methods and languages, and many of these repositories stores their content in different and incompatible format. Over the years, standardized language, methods, and formats has been developed to serve an interfaces between often priority and always idiosyncratic specific language and method. Such standard includes SQL, ODBC, JDBC, XQJ, ADONet, XLM, XQuery, XPath, and web services. Some of these standards enable translation of data from unconstructed such as HTML or free text file to structured such as XML or SQL. Structures such as connecting strings and DB-URL can attempt to standardize method of connecting the database. So student, let us now summarize what we have learned in this module. You have learned that magnetic data storage and its growth with advent of time and the advancement in technology. The first magnetic data stores used information stored on the surface of drum rather than disk. Drums were easier to design with the required tolerance and read-write head could be provided for each track staggered around the circumference. The first such storage was the result of an undertaking by IBM from their new 1952 San Jose, California laboratories to develop both a disk store, the IBM 350, and a computer system that was based around the use of online storage. The REMAC, Random Access Method for Accounting and Control, in 1956. The primary storage devices are like RAM and cache, etc. The various type of secondary storage devices like Winchester disk, magnetic drum, magnetic tape, optical disc, magnetic disc, etc. The magnetic material is normally in the form of tape, with the tape in its blank form being initially demagnetized. Digital recording. We learn about digital recording. Instead of creating the magnetization distribution in analog recording, digital recording only need two-stage magnetic states, which are plus ms and minus ms on the hysteresis loop. Magneto-optical recording. Write, read optically. When writing, the magnetic medium is heated locally by a laser, which induced a rapid decrease of coercive field. The reed head pulls a varying magnetic field across the gap, creating a varying magnetic field in the core and therefore a signal in the coil. Domains propagation memory is also called bubble memory. A high magnetocrystalline anisotropies gives rise to larger coercivities. Nanomagnetic materials have several morphology. So we have all learned all these things in this particular module. Thank you.